Hello there, Mr. Sutton here, bringing you the Algebra 2 10-1 Part 2 homework solutions on right triangle trigonometry, specifically dealing with applications with angle of depression and elevation. For most of these problems, we have to draw a diagram to describe the situation, and then we can go ahead and solve it for whatever they need. So in this case, we have a parasailer attached to a boat with a rope that's 72 feet long. Angle of elevation from the boat to the parasailer is 28 degrees. We want the parasailer's height above the boat, roughly. Alright, so we have an angle of elevation. That clues me in that I'm going to do a right side up sort of triangle here. And we have a rope that's 72 feet long. So I'm thinking, let's see here. This must be the boat. This must be the parasailer up here. So this must be the rope then, that's 72 feet long. And the angle of elevation from the boat to the parasailer, they said, was 28 degrees. So that's this right here. They want the parasailer's height above the boat. So that's this vertical distance on my triangle. I'll call it h. And now I'm going to go ahead and solve this. So based off of the sides that I have here, based off this angle, this is the opposite side that I'm trying to solve for, and I've already got the hypotenuse. So opposite hypotenuse, that's SO from SOHCAHTOA. So that's sine of theta equals opposite over hypotenuse. So I can write sine of 28 equals opposite side h over hypotenuse 72. And then to get h, I just multiply by 72. So 72 times the sine of 28. And I'll just run those numbers on the calculator. So making sure I'm in degrees mode for all of these, let me do 72 sine of 28. And that comes out to 33.8. And that's going to be in feet. For this one, we have a ladder leaning against a wall. The ladder has an angle of depression of 74 degrees apparently, and if the foot of the ladder is 65 or 6.5 feet from the wall, we want to know how long the ladder is. So ladder leaning against a wall, but they said we have an angle of depression. So I'm going to do an upside down triangle, but when I do this, it's a little bit weird. You have to visualize. Here's my ladder, that's this hypotenuse here, but the wall is actually over here to the left. So the angle of depression they're looking for is this angle in here. It's always between the horizontal and the hypotenuse. So we have an angle of depression of 74, that's this angle. The foot of the ladder is 6.5 feet from the wall, so that would be this distance right here. Here's the foot of the ladder, here's the wall, but it corresponds with this horizontal distance up here. So this is where I'm putting my 6.5 feet. And then how long is the ladder? That's this hypotenuse distance. So I've got the hypotenuse. I am looking for the adjacent side with respect to this 74 degree angle. So adjacent hypotenuse, that's cosine equals adjacent over hypotenuse is what I'm going to use here. So I can write cosine of 74 degrees equals adjacent side 6.5 over hypotenuse x. And then to get x by itself, I'm going to multiply both sides by x and then immediately divide by cosine of 74. So I've got 6.5 over cosine of 74. Let me run that on the calculator. So 6.5 divided by cosine 74. And I'm in degrees for this, and that's coming out to about 23.6 feet. For this problem, we are standing at the top of the Eiffel Tower, which is 984 feet tall. That's pretty high up. And you're looking down at a baguette in a basket, which is 50 feet from the base of the tower. What is your angle of depression to the baguette? And it is depressing because the baguette is not with us at the top of the tower, right? So if I'm doing angle of depression, I'm going to do an upside down sort of triangle as my model here. I could use a right side up if I tweak things, but I just think this way. So we know that let's see, here's the Eiffel Tower. We're right here at the top. The baguette is down here in the lower right. That's the setup here. So if the Eiffel Tower is 984 feet tall, well, that would be this distance on the left, but we're using this triangle, so that the vertical of this triangle is what we're going to give the 984 to. And then we're looking at a baguette 50 feet from the base of the tower. So that's this distance down here. but we're going to put it on this side up here because it's the same distance, so 50 feet up here. And we want the angle of depression, that's this angle between the horizontal and the hypotenuse. So based off this angle, I do not have the hypotenuse at all. I have the opposite and the adjacent sides. So opposite adjacent, that's the TOA part of SOHCAHTOA. So I can write tangent of theta equals opposite over adjacent. So in this case we have tangent of x, the angle, equals opposite side 984 divided by adjacent side 50. To get x by itself and get that angle, I have to take the tan inverse of both sides. So ultimately tan inverse of 984 over 50. And if I plug that in the calculator, I do tan exponent -1 and then parentheses. Let me do 984 divided by 50. And that comes out to approximately 87.1 degrees. For this one, in order to reach the top of a hill, which is 250 feet high, one must travel 2,000 feet along an inclined road which leads to the top. We want to find the measure of the angle of elevation. So elevation, let's do a right side up triangle here. Our hill, this is the top of the hill, and this is the road we're traveling on to get to the top. So this is 250 feet above the base here. And then this road itself is our 2,000 feet. And we want to find the angle of elevation, so that's this angle in the lower left between the horizontal and the hypotenuse. Alright, so I've got the opposite side over here from the angle, and I've also got the hypotenuse. O and H, that's the SO part of SOHCAHTOA, so sine of theta equals opposite over hypotenuse. So sine of x equals opposite side 250 over hypotenuse 2,000. To get the angle then, I need to do sine inverse of both sides. So sine inverse of 250 over 2,000. And if I run that on the calculator, I do sine -1 and then parentheses 250 divided by 2,000, and that should come out to about 7.2 degrees. So pretty shallow angle of elevation as these things go, although maybe for a road that's kind of steep. For this problem, they actually gave us a diagram. You're hiking near a canyon. While standing at A, which is right here, you measure an angle of 90 degrees between B, which is somewhere on the same side as you are, and C, which is somewhere on the other side of the canyon. You then walk to B. You couldn't walk to C, right? You walk to B, measure an angle of 76 degrees between A and C. So that's this lower left angle here. The distance between A and B is about 2 miles. I mean, you could easily measure that in your walk. We want to know how wide the canyon is between A and C. So it's kind of, you know, this darkness here looks like the canyon, but maybe there's more to it, just the way this picture is drawn. Maybe this is the actual side, the other side of the canyon over here, and this is all just kind of that inner wall. Anyway, we need this distance here. This is x. So based off of the angle that they gave me here, x is the opposite side, 2 is the adjacent side. Opposite adjacent is going to be a tangent situation, TOA. So tan equals opposite over adjacent. So specifically, I can write tan of 76 degrees equals opposite side x over adjacent side 2. And then to get x, I just do 2 times both sides. So 2 times the tan of 76. Let's run that on the calculator. 2 tan 76 in degrees mode gives us about 8.0 if I take it to the nearest tenth. So that's 8.0 miles from one side of the canyon to the other. That's pretty far. You're not walking that.